Chemistry can sometimes feel a bit chaotic, right? Like things just happen. But really, it's all about rules. And today, we're going to build the ultimate playbook for acid and base reactions. Seriously, by the time we're done, you're not just going to know what happens when you mix stuff, you'll actually be able to predict it. So let's dive right in. Okay, let's get real for a second. Ever had that awful burning feeling after a huge meal? Yeah, that's heartburn. And it's basically your stomach going into overdrive with acid production. But here's the cool part. The fix isn't some kind of magic pill. Nope. It's a chemical reaction, a very specific one that we're going to totally master today. This is chemistry happening inside your own body, and we're about to break it down piece by piece. All right, here's our game plan. We're going to tackle how acids deal with metals, then what happens with carbonates. After that, it's the main event, acid versus base. We'll even uncover some secret identities in the chemical world before we build our final playbook. Let's kick things off with acids and metals. All right, section 1. Let's talk about what happens when an acid meets a metal. This one can be pretty dramatic. Think fizzing, bubbling, the whole shebang. It's a really foundational reaction, and the best part is, it's super predictable once you know the rule. Okay, rule number 1 for the playbook. It's simple. Acid plus a metal gives you a salt and hydrogen gas. Think of it like this. The metal is more aggressive, so it comes in and literally kicks the hydrogen out of the acid to take its place. And remember, when we say salt in chemistry, we're not just talking about the stuff you put on your fries. It's any compound that's formed when that metal swaps places with the hydrogen. So let's look at a real-world example. Imagine we drop a piece of zinc metal into some sulfuric acid. What happens? Exactly what the rule says. The zinc pushes the hydrogen out of the way, creating zinc sulfate. That's our salt. And all those bubbles you see? That's pure hydrogen gas fizzing away. It follows the pattern perfectly. Okay, so we see bubbles. Lots of bubbles. But hey, this is science, right? We can't just assume it's hydrogen. How do we prove it? How can we be 100% sure that gas isn't just, I don't know, air? Well, lucky for us, there's a really famous and honestly kind of fun test for that. And here it is, the pop test. It is as simple as it sounds. You just collect some of that gas coming off the reaction, and then you bring a lit splint or a candle close to it. If it's hydrogen, pop. You get this awesome squeaky pop sound. There's no mistaking it. It's a super cool and totally reliable way to confirm you've made hydrogen. All right, on to our next big reaction type. And this one's all about that fizz. Like when you made a volcano for a science fair with baking soda and vinegar? That's exactly what we're talking about. So here's rule number 2 for our playbook. Anytime an acid reacts with a metal carbonate, you're always going to get 3 things: a salt, water, and, you guessed it, carbon dioxide. That CO2 is the celebrity here. It's the gas that makes all that exciting fizzing and bubbling happen. Let's put it to the test. Say we mix sodium carbonate, which is basically washing soda, with hydrochloric acid. What do we get? Well, we get sodium chloride, aka plain old table salt, some water, and a whole bunch of that carbon dioxide gas rushing out. Another perfect fit for our rule. And just like we had a test for hydrogen, there's a classic test for CO2 as well. It's called the lime water test. You take the gas that's bubbling off and pass it through lime water, which is just a clear solution of calcium hydroxide. If the clear liquid turns all milky and cloudy, bingo, that's your proof. That cloudiness is actually a new solid forming, and it only happens when carbon dioxide is present. Okay, it's time for the main event, the title fight, acid versus base. What happens when these two chemical opposites finally meet in the ring? This reaction is a big deal because it's exactly what's happening when an antacid saves you from heartburn. This reaction has the perfect name, neutralization. It's so simple, it's beautiful. An acid and a base literally cancel each other out. All their harsh reactive properties just disappear. And what are you left with? Just salt and plain old water. It's the ultimate chemical truths. The absolute classic example you'll see everywhere is mixing a super strong base, like sodium hydroxide, with a really strong acid, like hydrochloric acid. You take these two pretty dangerous chemicals, mix them together, and what do you get? Harmless salt water. It's incredible. They've completely neutralized each other. And there it is. We've come full circle. Remember that heartburn we talked about at the start? That's from too much hydrochloric acid in your stomach. And what's an antacid, like Tums or milk of magnesia? It's just a weak base. You're literally performing a neutralization reaction inside your own stomach to get relief. How cool is that? Okay, so we get how acids and bases react with each other directly. But chemistry has a few characters that like to work in disguise. Sometimes other compounds can step in and act like an acid or a base. Let's unmask these secret agents, a group called oxides. First, we have metallic oxides. That's just a fancy way of saying a metal bonded to oxygen, like copper oxide. Now, check this out. If you react copper oxide with an acid, you get salt and water. Wait a minute. Salt and water? Doesn't that sound familiar? That's exactly what a base does. So, because they act like bases, we call metallic oxides basic oxides. Simple as that. And you can probably guess what's coming next. Non-metallic oxides do the opposite. Think about carbon dioxide again. That's a non-metal, carbon, with oxygen. We already know it reacts with a base, the lime water, to make a salt and water. And what reacts with bases to make salt and water? Acids do. So we call non-metallic oxides acidic oxides. It's a perfect mirror image. So here's the big takeaway, the simple rule to remember. Metal oxides, they're basic. Non-metal oxides, they're acidic. Just by looking at whether it's a metal or non-metal in the oxide, you can predict how it's going to behave. It's a fantastic little shortcut that opens up a whole new set of reactions. Phew! We have covered a ton of ground. But now it's time to bring it all together. Let's assemble the final playbook, the ultimate cheat sheet that puts all these rules right at your fingertips. And here it is, the master playbook. 5 essential reaction types, all in one place. But don't just memorize it. Look at the patterns. See how salt and water keeps popping up? This isn't just about 5 random equations. It's about understanding the underlying system of how these chemicals interact. Once you really get this table, you'll be able to predict what's going to happen in tons of different reactions. It's a total game changer. So today, we've pretty much become experts on what happens in these reactions. We have our playbook, we know the rules. But there's a deeper question, isn't there? Why? Why do all acids act this way? What is the one thing they all have in common that makes them fizz with metals and neutralize bases? The secret? Well, it all boils down to a single, super powerful little ion. But digging into that, well, that's a story for another time.